let's talk in some detail about the TSMC example. And this takes a little bit of background to understand, where the semiconductor industry came from. So let me um, give a little background. So at the beginning of time, no, at the beginning when people were experimenting with different kinds of semiconductors, you would have people that would make, some silicon ingots and cut silicon wafers. So I'm drawing a wafer. That's what this is supposed to be. And, some people would, make gallium arsenide wafers. Because at the beginning, people didn't know silicon was going to become the dominant, material. In fact, at the beginning, there was germanium was one of the most interesting ones because people could make devices that were more impressive, early on. So, and people have to play with these things. So they become, sort of at the material level. There's a lot of innovation in materials at the beginning. Now, what happens is this is followed by the reason these materials are interesting is they feed into different kinds of devices. And so at this level, there's two things going on, processing and device innovation. So because of course I'm calling it the device level here, but don't forget you have to process these materials into these devices. And then these devices are sold into the marketplace and they go into things initially like computers. And can't spell. But computers weren't around for a while, so there's all sorts of other devices, radios, whatever that these things went into. And what happens is eventually there's so many applications up here that it starts to create a lot of demand for a particular kind of device, which was related to silicon electronic devices. They actually changed over time, but then that drove a particular material quite a bit. So let's fast forward to where silicon is really taking off because, why? There's a lot of end customers here that are pulling it up, okay? Now, the way that the company started to form then was that actually if you really needed to coordinate this over a large number of different kinds of companies, then it'd be kind of tough at the beginning because one person doesn't know what the other one's doing, right? So what you find out is at the beginning of industries, typically you have vertical integration. And what that means is that within one company, you make the material, which is a key added value when people don't have that expertise. When this is occurring, all this is new and people start to make devices and wow, we have customers. And so all of this is kind of, uniquely in this company for a while because this expertise is not known widely. And so we have an integrated thing where, these things are processed and then they go into some device. And then after a while, another invention, the integrated circuit, and then of course things like computers. So over time, this becomes a vertical industry. But then a funny thing starts to happen is that when the industry grows large enough, you tend to go away from vertical integration because the knowledge becomes widely known. So in reality, there may have been a few companies that vertically integrate all the computer, but really what happened was we had a lot of integrated circuit companies at the beginning. So what happened was you ended up with a lot of folks vertically integrated through here. So let's jump to my next example where now we're going to have many of these integrated circuit companies. So now we have, let's say, 5, and I'm not going to draw them all, but let's say we have 5 vertically integrated companies now, and they're doing their own materials, their own devices. I'm simplifying this again, processing and devices, and then their own integrated circuits. So we've got 5 of these, and all of a sudden, an enterprising young materials person comes along and realizes that this company has V1, volume 1, this company has V2, but the truth is that V1, they're on the same order of each other. Let's say they could be off by factors of 2 or something like that, but their volumes are, and this is of course why it takes a great number up here to develop before this makes sense. But I got 5 to 10. An enterprising young man or woman comes along and says, aha, what I'm going to do is that I am going to focus on making this lowest level for everyone. Now, in this particular case, and in a lot of cases, it starts at the bottom of the food chain. So why is that? One is it's the lowest value. Remember that these materials are made as they go up the food chain, they acquire value because of the processing put into them. So it's the lowest sort of value in the chain. Second is that because of the huge demand up here, what's happened is all those demand for silicon integrated circuits have matured a lot of the silicon device, but in particular it's matured the material even further, because you can imagine how the material has to be really, really reliable, and costs have to come down, and all these sorts of things as this whole thing drives. So it starts at the bottom because of those reasons, and some enterprising person comes along and says, all right, we have something that's called the volume cost curve, where the more stuff you make, the lower the cost. So the enterprising person comes along and says, aha, these guys here are at V1 and V2, whereas if I get all 5 of them together, or 10, or how many, and I supply it to all of them, or half of them, whatever it is, that's why you need, again, high volume. Let's call this V large. Then my costs are lower than theirs, and because it's becoming a standardized product, my product, I'll of course have the same thing. In fact, it'll be probably better in a lot of ways, but also it'll always be lower cost. And so this person starts to disaggregate the industry. So what happens is now you have this materials company, and its goal is to do horizontal integration. So its goal is, in a way, to go to higher and higher volume to supply more and more of these guys. And now they can concentrate all of their intellectual property and productivity on device and IC. They don't have to worry about materials anymore, and they can get rid of those fixed costs. Now, this only happens, of course, when there's a very successful growing industry that's large enough. And so in the case of silicon, that happened. Now, of course, it's only some matter of time. And in the book, Inside Real Innovation, we cover this in more detail. But there's an enterprising person named Morris Chang who, working at TI, noticed that there were more designs that in the IC space you could be growing faster if there was more access to these factories. So, of course, the second level started to become disaggregated, where he said, I'll make a manufacturing facility, a wafer processing, meaning that, I will take wafers, I will process into ICs. And again, it's because silicon with MOSFETs, had become kind of standardized, and there's like a roadmap for continued progress. And so this started what is called the silicon foundry business. It's a bit confusing because the materials are foundries for wafers, but this foundry part is sort of a foundry for integrated circuits, right? But the way the terminology has evolved is that it's called the silicon foundry. So you can read the whole story of an abbreviated story of Morris Chang inside inside the book, and it's also available, of course, online. But the bottom line is this created and still is the largest and most successful foundry so far, called TSMC, Taiwan Semiconductor Manufacturing Company, and of course a lot of benefit to Taiwan occurred by creating this model inside that country. So what this did was then disaggregated the industry into the last part, which is, of course, now you have the you might have heard of the fabless chip industry. And so these guys, they actually sell integrated circuits. They design them, but they actually don't have the manufacturing facility, and they don't make the wafers. So this evolution in each case, like in the materials case, and then in the case of Morris Chang, taking the processing part out of the integrated circuit company, these are all examples of implementation innovation, because notice how the technology is largely the same. There are some differences now starting to appear, but in general, it's because the technology was becoming somewhat standardized that this was possible, and they helped standardize it even more. And so that's why it's not really new technology, and it's not a new market either. I mean, it is in the sense that they made a market for their services, but if we look at this original, there's no new market application that's being created there yet. I mean, of course, later on there's new applications that these guys come up with, but that's their business anyway. So really the key is a very important example of implementation, where if you just look at technology and market, people leave TSMC off the map because they're kind of like, yeah, they were really successful. They became this gigantic industry, but I don't really understand them. Well, the reason they don't understand them is they're not properly thinking about innovation and one of the most important parts, which is implementation.